Welcome to the place where we gain knowledge through the lens of creativity. I am Aaron Dworkin, and this is Artful Science. Thanks again for joining me here on Artful Science. Today's show is the ethics of algorithms. Are our computers as biased as we are? And my guest is Aaron Roth, professor of computer and information science at the University of Pennsylvania's Computer Science Department. Welcome, namesake, to the show.
Thanks for having me. Good name.
So exactly. So it's so great that you're here, and I've always been, fascinated with this. So as an artist, I thought it would be best just to kind of start with the term algorithm, right? So I'm come from the arts and, and especially music and all of that. I hear algorithms all the time. I get a sense that they run everything, but what actually is an algorithm? Or is it just kind of a fancy word for a computer program?
Yeah, so let me start by being a linguistic curmudgeon here and talk about what algorithm has traditionally meant and then how its usage has been changing, especially in the popular media.
Oh, cool.
So as a computer scientist, like traditionally an algorithm has been more general and also more prosaic than a computer program. It's basically any well-defined set of instructions for doing anything at all. So a computer program would be an example of a formalized algorithm, but if you're just following a recipe to make a sourdough bread or something, that's also an algorithm. And we can talk about physical processes, the process by which your body transcribes DNA into RNA, also in algorithmic terms. So as a computer scientist, I sort of think of everything in the world as being algorithmic. It's just any kind of process whose rules you can pin down.
Gotcha. So, for example, just to kind of tie this into the arts, is that what you would say the example, would it be accurate to say that the score for the maestro for an orchestra, that is, they have the score, it's that roadmap for what the maestro and the orchestra is going to do that creates the music? Is the score the equivalent of a musical piece's algorithm?
I think that might be fair. Now, usually when we talk about algorithms, everything is supposed to be sort of completely well-defined. And so I'm imagining that the maestro has a little bit of room to improvise on top of the score, and that it matters who the maestro is. It's not enough to just put anyone who can read music in front of the score. But yeah, like I think at its most basic level, you could think of the score as being the algorithm for how to conduct the symphony.
Gotcha. Great. And I'm going to get to that kind of ability to, is there flexibility when it comes to algorithms? But before that, just so we can kind of have some real world examples, are there kind of current algorithms that affect our lives, the lives of, our audience here at Artful Science in a way that we might not know? Like we're like, oh, I didn't realize that was an algorithm that, makes that happen.
Yeah, there are. And let me now get to the way people currently use algorithms in the press, which, when someone says, algorithms are involved in hiring or in lending or criminal justice, often what they mean are statistical models that are the result of applying machine learning. So in the old days, the way computer programs were coded up is you'd have a software engineer or a team of software engineers, and you might be building something complicated, like Microsoft Word might have millions of lines of code, but in principle, there was a human being there, writing down exactly, the rules for what the program should do in every eventuality. Now, machine learning is different. Machine learning is basically the process of having the computer automatically search through some enormous space of algorithms, evaluating how well each performs on some data set that you've collected, and then producing the model, the algorithm that performs the best according to some like narrow measure of success that the machine learning engineer has specified. So the kinds of algorithms that result from machine learning are not human coded anymore. They are sort of the result of an automated search through some like vast set of rules you could apply. And machine learning is now used everywhere. So it's used not just for sort of mundane things like spam filtering and targeted advertising, but it's now used in lending. So if you apply for a credit card or a credit line increase, your application might never be seen by a human being. It might be sort of automatically approved or denied by one of these statistical models. In hiring, if you apply to a big company, their HR department might use automated screening tools based on machine learning to filter through resumes. And if you get an offer, what salary you're offered might be informed by statistical models. It's used in criminal justice. So in many states, including Pennsylvania, where I am, bail and parole decisions are informed by algorithmic risk models, which are trying to predict things like what is the chance that if you are released on parole, you will go on to commit another crime. And so it's really pervasive. So algorithms are used everywhere now.
Wow. So, and two kind of things there just light up for me, thinking about our, communities of color and thinking about artists and all of that, and thinking about what you mentioned about credit cards and criminal justice, and all of that, because it seems like there are so many inequities in this. And there are so many times where in my past or others who I know, I'm like, how on earth did you get turned down for that loan or that credit application? And or of course the imbalances in terms of the way criminal justice is applied. So of course this raises that question of bias. So if algorithms are involved in some of these decision-making processes, and I definitely didn't realize that in terms of criminal justice, like setting bail, I kind of, right, you always envision a judge is there and says, $10,000 bail, and they kind of have some guidelines maybe on a sheet, but not an algorithm generating it. The outcomes of a number of these things you've mentioned clearly seem to have bias. So are the algorithms biased, or how are we looking at that now?
Yeah. So these machine learning algorithms, at their heart, they're just looking for patterns in data. So it's tempting to say, oh, like the algorithm made the decision, racism or sexism, these are like human characteristics. We can't possibly be biased if we automated things, but that's not true. And it's not true for sort of a couple of reasons, some, mundane, some more interesting. But most basically, when you train one of these machine learning algorithms, it's just looking for patterns in data, and then it's trying to replicate them. So there's no particular reason to think that it would undo existing human biases if those are already represented in the data. For example, if I'm training a learning algorithm to replicate the hiring decisions made by my, human HR employees, the ones that have been made in the past few years, if they've been making sexist or racist decisions, well, like that's the pattern that's going to be learned by the model. So, it's important to understand that these things are driven by data, and oftentimes our human biases are already embedded in the decisions that the data reflects, and there's no reason to think that they're going to be undone. But the other thing is that machine learning doesn't do anything you didn't explicitly tell it to do. Right, so the beauty and the danger of computers is that they do exactly what you tell them to do, nothing more, nothing less. And in general, when you're training a machine learning algorithm, what you're telling the computer to do is to find the algorithm that best optimizes whatever you've set out for it to optimize, predictive accuracy, no matter what the other consequences are. And if the easiest way to do that is basically to do something along the lines of stereotyping, because maybe there's unmeasured variables in there that are like correlated with race, the algorithm will learn to make decisions based on whatever correlates are in the data. And maybe if you had been coding up the algorithm yourself, you would have not done that. You would have realized, of course, that's a bad idea. But because you weren't, because you just sort of told the computer to blindly search through this huge space of algorithms to find the one that like, you know, myopically like maximized predictive accuracy, well, that's what you get at the end. And so a lot of the work aimed at solving these problems is aimed at, you know, trying to figure out what exactly are the things that we don't want the algorithms to do, and how do we like, you know, tell the computer not to do those things. You have to the computer does exactly what you tell it to. You have to tell it what you want.
Wow. And is that kind of almost like algorithmic ethics? Like they're basically people who are kind of becoming experts in not actually planning or preparing the algorithm to solve the original problem, but actually all of the context in which the algorithm is going to exist and helping in that area?
Yeah. So I shy away from the term algorithmic ethics because I don't think that like, you know, algorithmic ethics are like distinct from human ethics. We should care about the decisions made on the ground, whether or not algorithms are involved. But there definitely is this science for trying to take, common sense human ethics, that, the kinds of expectations we would have of human decision makers in all of these important domains that somehow are, not always precisely specified. We know it when we see it. And thinking about how exactly to embed those kinds of desiderata, these ethical goals that we sort of already have, but never had to formalize precisely, and how we can use machine learning in ways that respect these ethical norms. And that's a big research area.
And so looking forward, where do you see algorithms going? Like, where do you think as a society we're going to be in, even just 10 to 15 years? Will things look substantively different?
So I don't think, well, who knows? It's hard work predicting the future, easier to predict the past. But I don't think that we're going to see sort of real differences in kind of how algorithms are being applied to everyday life, because they're already applied quite pervasively. And I don't think we're going to, see real qualitative differences in what they can do. I don't expect that we're going to have, like robot overlords walking around telling us what to do. But I think the current trends are going to continue. So I think that things will be increasingly automated. So when I talked about lending and hiring and parole, in almost none of these decisions, except maybe parts of lending, in almost none of these settings are the algorithms really themselves making the final call. They're still informing human judgment. But I think that we're going to see increasing automation, sort of, along a gradient. Things that have been, 5 or 10 years into the future for the last 20 years, maybe some of those things will finally happen. We might have autonomous cars in 15 years. Who knows?
Right. Awesome.
But I think we're going to see like everything we're seeing now, just more of it.
Gotcha. Well, this has been extraordinarily informative. We're just about out of time, but I always like to ask my guests, since we're here at this intersection of art and science, do you have any artistic practice that you do or that you love in terms of artistic disciplines?
So I've got 3 very small kids at home. So most of my artistic consumption is based around Disney at the moment. But I guess like many other people, I've taken up baking during the pandemic, both as a amateur baker and as an avid watcher of baking television.
Awesome. Well, Aaron Roth, thank you for helping us gain knowledge through the lens of creativity here on Artful Science.
Thanks for having me.